Hello everyone, welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Annie Talvasto, and I'm a CNCF ambassador as well as a senior product marketing manager at Camunda, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies, and they will build things and they will break things and they will answer all of your questions. So, join us every Wednesday to watch live. So this week we have two amazing speakers here with us to talk about enhancing your GitOps experience with Flux tools and extensions. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants as well as presenters. But now I'll hand it over to the speakers to kick off today's presentation.
All right, I guess we'll introduce ourselves. I'm Priyanka Ravi. I am a developer experience engineer at Weaveworks.
And I'm Kingdon Barrett. I'm an open source support engineer, also on the developer experience team at Weaveworks.
And a Flux.
And I'm a Flux maintainer.
Yeah. Okay, so I don't know if y'all can see my screen yet. I was just going to talk a little bit about Weaveworks real fast. Okay, so like we said, we both work at Weaveworks, and all the tools we're going to show you today are open source tools that are created by Weaveworks to enhance your Flux experience. So Weaveworks is founded on open source. We've donated a few projects, including Flux, to the CNCF, and we are the GitOps company. Our CEO, Alexis Richardson, coined the term back in 2017, and we've been helping DevOps teams with their cloud native journey ever since. So that's a little bit about us. And I'm going to talk a little bit about what is GitOps if you are not familiar with it. So GitOps is GitOps is an operating model for cloud native applications such as Kubernetes. It utilizes a version-controlled system, most commonly Git, as the single source of truth. It enables continuous delivery through automated deployment, monitoring, and management by a version-controlled system. You manage your infrastructure and applications declaratively. And there is an awesome group called the GitOps Working Group, and they manage the site called opengitops.dev. And in here, you can find a lot of information, including the GitOps principles that were developed by talking to a lot of users. And so these are kind of, if you don't meet all of these, don't think that you can't be using GitOps right away. These are kind of just what it should be in an ideal state. So you can get started using it and then add some of these in later too. The first one is that a system managed by GitOps must have its desired state expressed declaratively. The second is desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. Software agents automatically pull the desired state declarations from the source, so something like Flux, like we're going to be talking about. And then software agents continuously observe actual system state and attempt to apply the desired state. So you get away from things like configuration drift, and because things are written declaratively, there's a lot of benefits from that, including increased developer and operational productivity, enhanced developer experience, getting away from manual steps. You maybe aren't there on a weekend if someone did something wrong manually and you can't trace what was done. There's an improved stability, there's higher reliability, there's consistency and standardization, and stronger security guarantees as well. So that's a little bit about GitOps. What we are going to be talking about is Flux, and this is the repo for Flux, and basically what Flux is it is a set of Kubernetes controllers. And if you're not familiar with the concept of a controller in Kubernetes, it handles the life cycle of objects, what should be done when an object is created, deleted, updated, etc. And let me scroll down. So it's a tool for, it's a Git-centric package manager for your applications. And it's a set of continuous and progressive delivery solutions for Kubernetes. It's built with Kubernetes in mind, with a lot of the tools that are already existing in Kubernetes. So it's really just kind of drops in place in your already existing ecosystem very easily. And it really reduces developer burden because it removes the need for manual deployment processes. You don't have to worry about being on the right kube control version, whatever, right? You don't have to do all those. So, yeah, so if you want to check that out, there's also fantastic documentation here at fluxcd.io/docs as well. Then, let's see. Okay. Do you want to add anything? And if you want to add anything, Kingdom, just like jump in.
Please give us a star on GitHub if you haven't yet.
Yes, go here and
Great.
give us a star for sure. We'll drop a link to these as well. Okay, so one thing I want to mention, because I'm going to be doing a demo to show, the first one is we're going to show Weave GitOps, which is a UI that you can put on top of your Flux installation that you've already bootstrapped. And yeah, so it's a dashboard web UI. And then we're going to show, and to install that, we're actually going to be using a Helm chart, which is exciting to be able to show how easy it is to set up a Helm chart with Flux as well. And then I'm going to be using the VS Code extension, which is a really new feature as well. And I'm going to show that. So that's what I wanted to start with, just to because you're going to be seeing me use it in VS Code, even to set up the Weave GitOps UI. So you can find it in here. This is our new VS Code extension. It is still being updated and stuff. So if you do notice anything when you're using it, just let us know. Feel free to give us feedback. We love that. Kingdom actually works on it. So
yes,
yeah.
This is what I'm working on primarily these days.
Yeah. So if you do use it, please let us know what you think. And we're happy to, we're constantly making changes as well. So, all right. So let's go ahead and do this. So I'm going to open VS Code. So I already, let me back up for a second. I already went ahead and created a kind cluster. And 1 second, sorry. Yeah. So I created a kind cluster, and I ran a bootstrap command. So there's Flux has a CLI, and it's really awesome, super user friendly, very, very helpful as well. So if you need hints and you just do a help commands for any of the sub commands, it's great. It gives you exactly what the command's going to do, and then it also gives you suggestions for any flags. It has examples too, which is awesome. Can you
increase the resolution a bit, or maybe zoom in? If
yeah,
that
let me
would help
zoom.
to see. Yeah,
does that help? Does that work better?
A bit, maybe more.
I think it's just the video quality. I'm not sure if it's your internet or if there's anything we can do about it at this point. But
yeah, if it's purely resolution
it's
issue,
readable
then,
to me, I guess.
Okay.
Yeah, let's see if anyone else is experiencing issues. Let us know.
Right. And I'll try to scroll slow if that helps too. Okay, so this is the command I ran earlier. This Flux bootstrap command, and more.
And this is from the Getting Started guide. If you follow the Get Started with Flux guide on our Flux CD docs that was pointed out earlier, this will get you through. These are the basic things that we usually show in every presentation.
Right.
We're going to skip over some of these because we've got a lot to cover in more advanced topics.
Yeah. So yeah, it's what this bootstrap command is doing is if the repository doesn't exist. So in this case, I'm saying cncf -demo under my my GitHub. And so what it's going to do if the repository doesn't exist, it's going to create it. And okay, cool. And if it does exist, then it's fine. It'll just, it bootstraps into it. So what that means is it installs the Flux components, but it also puts all those files into that repo. So I can show that real fast.
Yes, so Bootstrap is Flux managing Flux. And that's what we want. We want everything on the cluster to be managed by Flux. Ultimately, that will give you the best coverage for disaster recovery and drift protection.
Yeah, so what that's done here is it's created 3 different files in here, but the first one is this GOTK components. And so this is creating the Flux system namespace. That's the default namespace that everything gets put in. All those controllers that I mentioned earlier, things like cluster role bindings, anything that's needed for Flux, all of those manifests are in here. And then in the GTK sync, the way that Flux works, there's multiple controllers, one being the source controller. And the source controller is actually listening to a source. In this case, it's a Git repository source. And you can have different things like a Helm repo source. There's multiple different sources. But in this case, Git repo source, and you tell it the URL. And what it does is every minute, in this case, it goes and checks for any manifests that are there, and it pulls those. And then the customization controller actually goes in and applies those manifests. And in this case, it's going to apply it in a 10-minute interval sync. And it's pointing to the Git repo source above it.
So just to point something about the intervals out, the Git repository interval is 1 minute. The customization interval is 10 minutes. But the customization, because it has a reference to the Git repository, is actually subscribed. So when the Git repository detects changes, they go out immediately through the customization.
I just saw something about, I might want to zoom in. Okay, so yeah, and along with that too, the 10-minute thing is nice because if something happens, like if some configuration drift happens, some bad actor comes in and deletes one of the deployments or whatever, right? This customization every 10 minutes will ensure that that stands back up. So yes, that's really awesome as well. Okay, so there's that. I'm just gonna add it to this. Okay, so there's that. So now I'm going to go into VS Code and do this getting started back. Okay, so this Weave GitOps expects that you've already bootstrapped Flux. It's going to then be installed on top of it, and it's going to be listening to your Flux stuff. So what I'm going to do now is I'm going to use this terminal. So maybe I'll use the other one so it's bigger. I'll keep using this one. Okay. So I am going to, let me make sure I'm in the right. I'm going to create a password first for Weave GitOps for like actually logging in. So I'm going to do password equals, I'm just going to do test or something. I don't know. Not the best password to have, but yeah. So, and then I'm going to run this command. And so you can find all these steps on that doc that I showed briefly here. So it's this getting started with Weave GitOps doc. And you can follow along in here too. So.
Perfect. And then there's an audience question coming in. And keep them coming, everyone, by the way. Ask your questions already now or during the Q&A in the end. So Laurentinas asks, is that code for configuring Flux, configuring cluster, or both?
So we've already configured Flux with the bootstrap. Configuring the cluster was done before that off stream. It's a kind cluster, so there's not really much to configure. We'll get back to that later because there's some configuration, but it's.
And I'm assuming they're talking about this code, right? Yeah.
Yeah, the Git repository and the customization are the underpinning of Flux. Those two work together to deliver resources to the cluster. And what we're about to demonstrate now is how you can deliver a slightly more advanced software package that requires some configuration itself through Helm, and do that in a declarative way with Flux. So this is really two-part, two payoffs we get from this demo. We get to show you Weave GitOps, and we get to show you how to install any software package that's distributed through Helm.
Yeah,
perfect. Is this a good time to take another audience question?
Yeah, go ahead. Yeah, Kingdom KQB.
Yeah. Daniel asks, what is your recommendation on onboarding a service to Flux? For instance, from centralized cluster that has Flux installed, what is a good way to onboard a service to a particular environment?
Well, we're going to show two strategies today. After we get through with our Weave GitOps installation here, which is really about installing a piece of software from a vendor, so that's onboarding in a way. Then there are two scenarios that we're going to show. One is I'm a developer and I'm building software using Docker build in CI, and I want that image to be deployed automatically. And then the further scenario that we'll show after that is a more production-oriented scenario where we're going to have, we don't really just want the image to be updated. We might have some manifests that need to change too because it's a new release of the app, and who knows what is going to change from one release to the next. So we'll talk a little bit about semantic versioning too while we're in here.
Yeah. So what I did real quick was, I don't know if y'all can see this. Let me get rid of the least that. Maybe this is good. Okay. So what I did is I added a, oh, wait, I did it twice. 1 second. Okay. So I added a, no, wait, that's not what
No, I think you just
I'm
deleted
on the wrong file.
Yeah.
Yeah. Let me leave that alone.
Yeah. So this file says do not edit. That's because
Yeah.
it's created by
I
Bootstrap.
don't know what I opened. Oh, here it is.
And here we go. Yes,
Yeah.
it goes in here.
Okay,
So we're grouping resources together in the same file. As you can do it that way, or you can put them in separate files. It's okay.
Yes. So I used the Flux CLI real quick to just create the source and the customization. So there's multiple ways you can do that. Obviously, the CLI is a really good way to do it. And then I did the export command, which then doesn't actually create the source. What it does is it actually creates the YAML. And that way you can push it to Git and let it manage itself. And then I created, like, so I'm going to grab this password real fast. So, and then I'm going to put it, replace this one in here.
So these values are copied from the example in the Getting Started guide for Weave GitOps, if that wasn't clear.
So what this is doing is I said that the source controller can also listen to a Helm repo. So this is actually pointing to a Helm repository, the Weaveworks one. And then what the Helm release is saying is stand up this chart, but then also with these specific values. So this is a really cool way to override your values and everything. And then, yeah, so it's specifically the Weave GitOps chart. And yeah. Sorry, got distracted. Okay, so I'm going to save this, and then I'm going to push it to Git.
So I saw you put this in the Flux system directory, and there's a customization.yaml file here.
You know me. You know me so well.
We have to add it here because this file exists. If this file is here, it needs to have the whole list of all the manifests to apply. If this file is missing, Flux will just slurp up everything that's in the directory, and that's fine too. But we're going to show some of the functionality of Customize in terms of resources and bases, and you can connect. I'm not sure how much of that we're actually going to show today, but we have a few things that do use that. So there, just skip one error.
Perfect.
That wasn't your intentional comment, was it? Your error that...
No. It's, you know how I am. I always forget to add it to the customization file, and then I complain about it.
That's why I stopped you. I figured it would
Thank you. It's like, I can't. I don't know. Numerous demos, and I always forget. Okay, so the neat thing about the VS Code extension is, well, one of the neat things. There's several neat things, but the fact that you can see the sources, you can see the workloads in here, and then you can actually go in, reconcile them, and so force them to actually go and fetch, and then suspend them. So let's say you were making a change in Git, but you didn't actually want it to be realized in your cluster yet. You can suspend either the sources, you can also suspend the workloads, and that way it won't actually realize that change until you resume it again. So I am a really big fan of this extension. I think it's really neat to be able to just code and then also apply these changes right away. So, and then you can see it in the output that it did fetch that.
It's all about minimizing context switch. If you have to go find a terminal in order to figure out if it worked or not, you're already host. You lost your focus. Yeah,
and if it had failed, it would be a red X as well. So
hopefully something will go wrong sooner or later.
Yeah, maybe I should have left it. Well, it wouldn't have failed, but it would have just not applied it. And I would have been like, why? Okay,
Great.
so now if we go in
There's
here,
2 more audience questions, by the
Yeah, go
way, if
ahead.
you want to take them now. We can always just take them in portions as well. But there's, for example, Sankara asks, can the Git repository configured in the Flux Bootstrap be local clone? That is, can this be used in a test environment where a developer has pushed changes in a local repo and wants to deploy the update in some cluster for testing?
That's a good question. So the Git repo has to be addressable from the Kubernetes cluster. So it has to be hosted somewhere. It cannot be a local repository on your hard drive that doesn't live on a network anywhere. But there are examples. We've had, I host a weekly meetup called the Flux Bug Scrub, and we have a YouTube channel where you can see sometimes we have a presenter. We did have one presenter who wanted almost exactly what you just described, who added DNS entry through Core DNS, and it was a really neat presentation to show how local you can make it if you can host. Like, can I host a Git repository in Docker adjacent to the kind cluster? Yes, and we have examples of that. So we're
Great.
logged in here.
Then there was another one as well. If you leave off the -- export flag, is the change made immediately?
yes. So if I left off the -- export flag when I was creating a source, it would just create a source.
Directly in the cluster without putting it
directly.
in the Git repository.
Which
So
isn't really in the spirit of GitOps. So you do want to do the export and push it. But you can also create it and then, so it's not like, end all. If you
there's also Flux export. If you do it in the opposite order, just because you'd like to know that it works before you commit it to the Git repo, that's a really helpful workflow too. So you can Flux export a Git repo or anything else that you create through the Flux CLI.
Yeah.
Great. There was one more question, or do we want to
go ahead.
move a bit more forward in the demo?
Let's queue a couple up here. Let's see if we can make some progress. We have a lot of points to cover. And
okay. Let me just show this UI real fast.
Yeah.
And then So in this Weave GitOps UI, you have the application. So this is showing, in this case, the customization for Flux system, the one that we bootstrapped, and then the Weave GitOps Helm release itself. And if you go to sources, then you can actually see all the sources that are created. And so these are the ones that we've created in the Flux system namespace. And then Flux runtime actually shows all of the different controllers that are part of the Flux runtime. One thing I didn't mention really quickly is that if you do bootstrap, just base bootstrap command, then it won't install the image controllers. So there is a little extra flag to add that you can say add these additional controllers as well. So I did that when I bootstrapped, so that's why they're here. And
components
then
extra if you caught it or if you didn't. That's how it's
sorry?
called. Components extra is the name of the flag.
Yeah. And then if I click on these, I can actually see the different components that are in this managed application. And then in events, you can actually see the events that have been going on. There's a graph to see the breakdown. I think it's better if I show this in later when I do the pod info example, but so I'll come back to that. And then YAML. And then as I mentioned earlier about being able to sync and suspend in the VS Code extension, you can also do it in here as well. You can hit the sync button to force a reconciliation, or you can suspend and resume it here as well. So that's the UI in a nutshell. Now I'm going to deploy, we'll answer these questions first, but basically what I'm going to do in a second is I'm going to deploy a pod info application using the image automation controllers as well. And then I'll briefly show it in here, what it looks like. And that way you can kind of see how the image automation controller works. And then I'll pass it off to Kingdon. Okay, so we'll answer some questions real fast.
So we had one question about, two questions about declarative principles. Is it okay to use external secrets? And is it okay to use templating tools like Helm and Customize to template your YAML and then apply from the YAML? So Flux itself has Customize built in. So we obviously don't think that it's against declarative principles. Flux Customize controller is limited in what it can use in terms of external plugins. since those involve a shell out, and that's where we found the vast majority of security issues creep in, we don't support that type of behavior. So we'll sort of limit you to the more declarative things that you can do and shun you away from the imperative things that you could do with customize in a different scenario. Templating a Helm chart is something that you can do. No one will stop you, but the question is, what do you do with the template, and will it break your Helm charts? Because that's how some other Helm tools work, and they'll template out Helm, and Helm has these hooks that are lifecycle hooks for when a chart is installed or upgraded for things like we need to migrate a database. And those things have to happen in a certain order. Sometimes the way that templating shakes out, they don't happen in that order. So the point of Helm Controller is to be as close to Helm as possible and to do things the Helm way everywhere. So we wouldn't recommend usually to do templating in Helm because we support Helm on the metal, I guess is the best way to say it. And as far as external secrets, no, I don't think that's against declarative principles. There are some guides on how to do secrets with Flux. You can use SOPs, for example. That's the one we support the most. But we also have integrations with HashiCorp Vault, and there are a lot of docs supporting how you can do GitOps and declarative secrets that way. Other tools like KMS that are not necessarily open source for various cloud vendors, those are also supported through SOPs.
Yeah. I think that's all, right? Oh.
Was the Daniel's question about monitoring the Flux GitOps deployment status in there already, or?
So there is.
I haven't tried Loki myself yet. I've heard that's very good. Yeah, so there's a Flux monitoring guide that will show you how to set up Flux with Kube Prometheus stack and all of the Flux-related Grafana dashboards. We always want to mention this too when we're talking about Flux UIs broadly, because this is the original Flux UI, is the Grafana dashboard. There is one dashboard for Flux controller status or control plane, and another dashboard for Flux's workloads to show you if any Git repositories have failed to sync, for example. There's an alert manager configuration that will help you see if any Flux resources are not reconciling for longer than 10 minutes. Those are definitely key for production Flux deployments.
Yeah. Yeah, so if there was like a Helm chart or anything like that, you could set up, like you said, notifications to let you know.
Yeah, and at the base level, when you're having issues with Flux, you want to go in and start describing resources, because every resource that Flux has will raise events as things are happening. So if you have an error with a Helm release, it may say Helm chart did not exist or was not ready. And then you can go look at the Helm chart CRD and see, oh, what was it that went wrong? Was it an authentication failure? And you'll get those details in events. They show up at the bottom of the describe block, or if you have another system like Loki for consuming Kubernetes events, they'll show up in that. Okay, I think we better try to.
Yeah. Okay. So one thing I wanted to mention real fast is that we're about to use this pod info application that probably a lot of people, like I know a lot of people are familiar with already, but Kingdom made a couple of changes, and so we basically just added an ingress so that I don't have to do port forwarding and all that stuff. So we discovered this cool thing, and we just wanted to show it to y'all real fast. So in Kind, when you are setting up the cluster, you can actually create the cluster with this and with these settings, and then if you install one of these, you can actually just use an ingress normally. So this this was just like a cool thing that we.
So yeah, well, why do you use an ingress instead of port forwarding? The main reason is port forwarding is a clunky, very devish solution for getting access to a pod, and it gets you access to exactly one pod. So for a demo like Flux or Flagger, if we were doing a Flagger demo, especially when you want to be able to access multiple pods and see the transition between them, it's not really a great way to do a demo. So we wanted to have Ingress. Unfortunately, Kind has these great documentation now about exactly how to do an Ingress controller in a Kind cluster. There are about 3 steps to get it working. It's really easy compared to a year or more ago.
Yeah. So I have already set up the YAML, so I'm just going to copy and paste it, but then I'm going to walk through it real fast. So this is pointing to a, so the original pod info project is under Stefan, and Kingdon's forked that, and then I forked Kingdon's project. So the one that I'm pointing to is a fork of a fork. And so mostly because we were just testing out image automation stuff. So that's what the source is pointing to. And then what we've done is we have 2 separate customizations in this case that are pointing to the same source. And the first one is pointing specifically to this specific, like this path within that repo. And then the second one is pointing to this .customize path. So what those are real quick is, oh, wait, sorry. The deploy overlays automate. Okay, so in here it's actually setting up the we have our image policy, our image repo, our image automation set up. So if I start with our I guess I'll start with the image auto.yaml. This is well, my mouse died. Sorry, 1 second. Okay, so this is actually setting up our image automation, like image update automation stuff.
So these are all the parameters for the thing that actually writes a commit.
Right.
There are 3 parts to the Flux image automation. There's image update automation, this resource. There's an image policy resource that says what image, how do we know which image is the latest and which images to select from. So that's a regular expression there. We'll see what kind of image tag that matches in a sec. And then the third thing is an image repository. For the image reflector controller, this just reflects a tag list. So it goes and looks at that public OCI repository with images in it and says, this is a list of images. They get filtered through the image policy. The image update automation looks for the latest. If it's different than what's in the repo already, it will write a commit and update the repo with that new image. So that's what we'll see.
And then one thing in here just to point out is this. So what we're doing is we have a dev branch. And Kingdon and I wanted to show what it would look like to just have a dev branch that's continuously being updated regardless of what version it is, right? Major, whatever, because it's a dev branch. And so what we came across is an accidental loop where in the actions, we have it actually set to build an image if there's a change made. And then also, this is going to make a change to all the image versions in here. So every time it made a change, it would kick off the action. And then, yeah, so it's back and forth. So this is to actually tell it to CI skip when it's doing the image automation. So, yeah.
And these 2 parameters for the dev branch, maybe we should explain those as long as we're in here. One points at the branch to checkout, and the other is the branch to push to. So those can be the same or they can be different. The idea being maybe you want a main branch to be the starting point and you want to create a pull request from that. There are those examples in the docs. This is just a single branch to keep things simple. Imagine it's a dev branch, and this is where all of our changes go.
I added it to the customization this time. Okay, so now if we go in here and we reconcile, And like Kingdon said, when the source finds a new version, it will also kick off the customization. So that's why I'm not like also then going in and reconciling the customization as well. All right, let's see. I think it might just be running. Oh, right. I made a note of this and then I. Okay, so I have to also create a secret because it needs to have access to right to the repo as well, right? So let me go do that real fast.
Yeah, so the Bootstrap steps only create a read-only deploy token in the in the cluster by default. You can bootstrap with a read-write token if you want, but this is the point where we always point out how potentially dangerous it is to have a read-write deploy key anywhere. And one of the reasons why we wanted to highlight the difference between how you might do this in dev versus how you do it in production. But obviously, branch protection policies are something you should consider if you're using something like this, so that you don't have the possibility that you will, your deploy key is compromised somehow, and then your main branch is overwritten with whatever the hackers put in there.
It's this one, right?
Yeah, that looks right.
Okay, but I mean, I just have to change the me.
There's been a few audience questions as well, if we have a good time to go through them at some point, but we can also, power through sections of the demo if that works better.
So I just ran that command to create a deploy key, and then I'm going to go into my project and put it in there. You can ask the question. I think it's okay.
Okay, so we had Sheer asking, according to the declarative principle, there should be no processes between the desired and actual state. So doesn't decrypting secrets go against that?
So I think the question is really about hermeticity. The question is the cluster reaching outside of itself to find anything? And the answer is yes, it is, always, all the time. If we're doing GitOps, the Git repo almost certainly does not live inside the cluster. It will live on GitHub, or it will live on a remote server somewhere that can survive a disaster that downs the cluster. That's the point. So it's not a violation of Git of declarative principles or GitOps principles to reach outside of the cluster for something. And it is not really a violation to do something functional in between, something without side effects. That's, I guess that's what we're talking about. So, I mean, you can have a side effect. That could be, we've rotated the secrets outside of Git, and now we don't have a way to recover the cluster into the exact state that it was before. So yes, this is a way that you can shoot yourself in the foot. Be careful. There are two different models. You can have secrets in the Git repo, which has its own set of drawbacks. Those secrets obviously have to be encrypted. Those encryption keys have to be protected. And then the possibility that they are ever compromised, you need to have a plan in place to rotate them. Those things are also all true if you keep the secrets outside of the Git repo. So it is complicated to handle secrets. That's really the nutshell version of the answer. And you don't want secrets in the open, or they won't be secrets for long, especially if they're secrets that can compromise critical parts of your deployment infrastructure, like your Git repository or your cluster admin credentials. Those are all possibilities that you need to be aware of and engineer around. So Flux does the most conservative thing by default. That's one of the design principles of Flux.
Okay, so sorry, that was I don't know if y'all noticed me fumbling. Okay, so I forgot that we named the secret very specifically, so that I just had to update that. So now this is running. So the image automation is also running, and the pod info stuff is deployed as well. So if I, it was podinfo.local, right?
Yay!
Yeah, hey. So we can see here it's deployed, and we can see that the version is 6.15-alpha.1. In the pod info project, we have this. Did I not have it open somewhere? I did.
Handy dandy makefile, right?
Yeah. We have this makefile. So if I go down here, in this makefile, there's a command called version set, and we can use that to basically show y'all how the image update would be. I'm going to run a command real fast.
So there's a chicken and the egg problem that this version set represents. And Flux, we've been talking about how Flux can update manifests to point at the latest version of the image. Here we're doing it in the makefile. Imagine that this is part of your CI or your release process. We'll do it manually instead. And that is to avoid the chicken and egg problem that Flux can only tell you about images that have already been built. And we'd like for this version number to be correct in the image. It shouldn't refer to the previous image in a new image. So, or in the tag. Maybe those manifests don't actually go into the image itself. All right, so we updated the source code and the manifests to have this new version number in it. We're going to push a new commit here, and that's going to trigger a Docker build. Yeah, we've got a commit that we have to rebase over because the automation is also working in the background.
Now
right, so this is going to trigger a Docker build.
Right.
And this Docker build is based on a new example that was added to the Flux docs very recently in the
here.
use cases section. It's
by the way, while we see this, VK asked, is there recording? This is not a recording. This is live, and we're going to get to the audience questions soon. So don't worry, VK, your question will be answered.
I had it somewhere.
Yes, the Git repo that we're working out of right now is github.com/Priyanka-Ravi, Priyanka-Ravi/podinfo. And there's another fork at kingdomb/podinfo that I've been working on. So we'll see that at the end if we get all the way to the end. We're doing a dev deployment now from this dev image. We'll do a slightly different deployment at the end with a Helm chart that's pushed to an OCI repo. So the reason why we're working out of several different forks is to have what we really wanted to show was like this concept that you would have some people are working in their own forks, and then there's a main fork that the org owns. So pretend that I'm the org because we don't have Stefan here today. It's his original work, but we basically hollowed out the GitHub workflows just to demonstrate this really simple workflow because PodInfo is really a staging ground for all sorts of new and advanced features. If you go and look at what Stefan Prodan has done in his original PodInfo repo, there are a lot of really advanced GitHub workflows in there, and there are some that go back quite a ways. There's one to publish a Helm chart to a Helm repository. There's one to do a cosign trustless artifact verification. I don't really know the details about how that works, but it's an example that's in there, and there are details on the Flux blog about how you can do cosign verification and what we're building around cosign in the Flux project now. But I really wanted to have an example in the Flux docs of what is the simplest builder that you need. You don't, because we've got a lot of people that come for support who have big involved CI pipelines, and they want to know if they can use them with Flux. And the answer is usually yes. If it produces a container image, then yes, you can use it with Flux. But we get pretty unsatisfactory results from answering the question that way. It's probably better to show people what's the minimum viable answer. So even though Flux considers CI completely outside of its own responsibilities, we did add a document showing how to do CI with GitHub Actions and a few other GitHub Actions related docs. Also other CI platforms like Jenkins. So our build succeeded. There's a new image out there now. Flux may not have seen it yet, but any moment now we should see response from the new one with alpha.2, I think, right? You did version 7.
Yeah, that's what I put it as. Him.
Sheer just asked a question about OCI, Helm repositories, and renewing the token when pulling the chart. There is documentation about how to renew a token. I think that there's our new app. All right, yay, it worked. So we didn't have to update any manifests. Flux did that. If you go find the commit that it made, you can git pull that commit and see exactly what it changed, or you can check it out here. Excuse me. So back to the question about renewing the token. This is kind of a specific question. We have examples in the docs about how to interact with ECR. They're not specifically focused on Helm yet because this is a new feature and we're building more features around it. But yes, there is support in the docs for, if you search for ECR in the Flux docs, you'll find a lot of information, including how to write a job that will renew the token. There is an auto login feature. I'm not sure that that has made it all the way to the Helm repository OCI feature yet. So if not now, then soon. You will also be able to leverage cloud credentials like IAM roles to connect to an ECR, and you won't have to manage renewing the token yourself.
Yeah. Great. Then there was another question from Sure, which was, are there any features that Flux has compared to Argo CD?
There are certainly a lot of features that are, these two projects track each other pretty closely in terms of new features. When Argo CD comes out with a new feature, we're always hearing about it, and we have people coming and asking, can we get this in Flux too? Application sets is a great example of that. And so Flux has this native Helm support. That's one thing that's definitely has over Argo CD, in my opinion. Is there anything else that we can highlight about the difference between Flux and Argo CD? I know that there are blog posts out there about the specific topic,
Right.
But they are always getting out of date because it's a big competition. We'd love to be able to say that Flux does all these things that Argo CD doesn't, and it never shakes out that way because everybody's trying to keep up with everybody else. It's great.
The Terraform Controller is a cool one, I guess.
Terraform Controller,
yeah,
that's a new feature that it's built on. I think the architecture is the most unique feature of Flux. So performance based on that architecture is also something to call attention to. Flux has a very low footprint on the cluster. It can run in a few hundred megabytes. Helm itself is not very, it was not architected to run as a server. It was architected to run as a CLI. So it doesn't have the same focus on low memory usage and performance in terms of stateful workloads. But all right, so we wanted to talk a little bit about semantic versions and what does the version number mean. We have a semantic version number here with a pre-release tag. So the dash suggests that this is not a release version, but a pre-release with some information after the dash. And if you want the details about semantic versioning, there's semver.org, but rather than read the spec, I thought we could talk about Semver and how you compare it to another versioning strategy that's not Semver, like marketing versions. If everyone's ever heard of marketing version, this is not really a scheme so much as just a way that things are done. This is the the number go up approach to versioning, where when you have new features and you want to highlight a particular release, you make the first number bigger, and it's great news because we have a new version number. This is totally different than semantic versioning, where the new number in the major place means you need to watch out because something is going to break when you do this upgrade, and it's a different type of versioning. So when we're using semantic versions, we'll Helm charts, for example, are semantically versioned. That's one of the requirements of Helm chart. And maybe this is a good time to share my screen here so I can show the Helm version of this in production here. So, okay, so I have a few namespaces here. I have one podinfo helm OCI namespace where I've installed using a Helm release. Let's see if I have the right editor window. So can everyone see my screen, by the way? Is this okay? In our deploy directory, in the overlays directory, this is where we were looking before. We have this example Helm OCI that we have deployed this cluster. And we'll show a Helm release and a Helm repository that make up this Helm OCI. So this has a lot less in it than the Helm release we saw before. I haven't specified a version number. I haven't specified any values. We're just installing this chart with the default values. And we're going to put it into this target namespace, podinfo helm OCI. And here's our Helm repository. This is the new feature, this type OCI. If you'd like to take advantage of an OCI Helm repository, you can point at something like this. This one happens to be public, and so there's no secret required. And if I go to my podinfo directory where I had released version 6.1.18, I'm going to release a new version. So I need to update the source code to reflect that new version. We saw that happening already once in Pinky's example. Signing my commit. Don't have to, but you can. And then I'm going to tag that and push that tag. And that is going to trigger the Docker build workflow similarly. Here's our podinfo repo.
Quick question from the audience. I hope quick. Does it support internal repos, something like Artifactory?
Yes. Yes, Artifactory is definitely on the supported list. We have support for any kind of Helm repos that are out there now, I think. We also support GitLab. What else are people using? Off the top of my head, I can't think of another one besides Chart Museum. But there are definitely... the Helm repository format itself is really simple. There's an index.yaml at the root that has a list of every version of every chart. And this is the reason why it doesn't scale particularly well. This is why OCI is such a big advancement for us and why we're so excited about it. Because fetching a list of tags is very efficient compared to fetching a YAML file that's full of metadata above and beyond just the tag number itself. So I want to make sure that we don't miss this deployment here. So you see 51 minutes ago, we had a deployment. And like I said, it's just going to select the latest release based on this manifest. So there's no version number, so it's just using semantic versioning to determine which one is the latest with no restrictions, and it'll install that. Did we have any other questions? Yeah, a basic web server is all that's needed for a Helm repository. You don't have to have anything special. Okay, so this is finished. And let's go and take a look in here at exactly what we did. I want to call out this step here because this is different than what's in the docs. We used Helm Push. So in a previous step, we did Helm lint and Helm package, and then Helm Push from the artifact. This is just pushing a tar GZ file to an OCI target, and this is a built-in feature of Helm. And I wanted to call this out because next month I'll be showing a brand new feature in Flux, which is this rehashed for customizations. So instead of requiring you to use a Helm chart to get this behavior, and this behavior, by that I mean atomic releases where we see this happening, all the configuration comes with the new image and they get released at the time that you say, not necessarily at the time that the new image is first available. This is better because you like to test your artifacts before you put them in production, and you simply can't use Flux's original image update automation in that way. It only monitors for new images and pushes them out immediately. So you can add a kludge so that there's a pull request between this point and that point. But really what you'd probably like is to separate build, publish from release. And that's what this accomplishes. We get to publish our artifact, test it out, and then release it at our leisure later or automatically through Flux. So that's what's just happened here.
We have a few minutes left. So if anyone has any super quick questions from the audience, you can leave them to the Q&A chat now, but we have to start wrapping up soon as well.
I did want to just mention the Terraform Controller real fast. So it's another one of Weaveworks' created tools, and it's kind of the newest one. It's the what it is you can do manual approvals or auto approve. So basically you can manage all your Terraform resources regardless of whether they're in Kubernetes or not. But it is kind of like a nice marrying with GitOps and Terraform. So it's still using the GitOps workflow. There is a TFCTL CLI that's really awesome. It also most recently has integration with Terraform Cloud and Terraform Enterprise, which is really cool. And you can even set the outputs into a Kubernetes secret as well. So I do have a demo already out there on that you can find on our Weaveworks YouTube channel. So if you are interested in learning how to GitOpsify your Terraform deployments, you can go check that out as well.
Perfect. So we had a few questions, really quick answers, hopefully. When referencing a third-party Helm chart, can I use values file in my GitHub repo?
Yes, there's a feature. You can select a different values file. So like values production, that you can do that. There's, if you have different values files, you can select them, you can group them together and merge them. Those things are all possible.
Perfect. So then further diving into Flux and Argo. So how does Flux compare to functionality in Argo like sync wave and phases?
I'm not familiar with phases, but I heard of sync waves before, and my understanding of how they work is that you sort of give everything a number and they sync in that order. The way that we do it in Flux is more explicit. There's a depends on statement. You can say this customization depends on another one. And then in each customization or Helm release, you have an option of whether it should do health checking or not. So sometimes you just want to, like, I need this CRD to be installed in the cluster. I don't care if anything's ready. You can have dependency that doesn't wait and works that way, or you can have a dependency that waits where, say, you have some admission controllers and we really want to be sure that they're firing before we let any of our tenants try to put anything on the cluster. Because they're bad people and they're going to break it if we allow them to. That way you enable wait, and then there's health checking that gets performed, and that's part of the dependency check too.
Perfect. Then final question, hopefully with a quick answer again, related to the third-party Helm chart question before. If the values file is from a different repo than the chart question mark.
So you can incorporate values from config maps on the cluster. You can incorporate values from other sources. The values are composed in the Helm release itself. So wherever the Helm release comes from, you can bring in values from where that is. You can also, there's a feature we didn't show today where Git repositories can be composed together. So if you have resources that are in two different Git repositories, it kind of works like submodule, but it's a little bit better in some ways. It has better performance characteristics and caching. So if you do have things that are in separate repos and they need to be brought together, yeah, Flux can do that as well.
Yeah, perfect. That wraps it up. Thank you so much to our amazing speakers. Really nice, quick answers in the end as well. I love it. So thank you everyone for joining the latest episode of Cloud Native Live. It was a really great to have a session about enhancing your GitOps experience with Flux tools and extension, and really love the audience interaction this time as well. Thank you so much everyone for your questions and comments. Yeah. Next week, we will have a session on using Litmus Chaos Engine and microservices demo app to demonstrate automated RCA. So thanks for joining today, and hope to see you next week.
Super.